All right, let's dive into this ammonia thing.
Yeah.
Not the cleaning kind, though.
No.
This is ammonia as a...
Potential fuel source.
yeah, a fuel source, but it starts out in fertilizer. I think what's really fascinating about this is how it moves beyond just like a scientific breakthrough.
Yeah.
Bosch really understood how to take existing expertise
Right.
and apply it to new problems.
Yeah.
And that's a lesson that,
Absolutely.
anyone could take away
For sure.
from this story.
That's what struck me, too, is it's not just about ammonia.
No.
His mastery of high pressure has implications for
So many things.
so many other things.
Yeah.
But let's go back to the beginning.
Okay.
How did Bosch's work on ammonia production actually start?
Well, it started with a problem.
You see the process of creating ammonia. It produced carbon dioxide as a byproduct, and they saw it as, back then, as just that waste.
Yeah.
But Bosch, with his innovative thinking, he saw opportunity there.
Okay.
He thought, why not use the CO2 to create something valuable? And that's what he did.
So he turned trash into treasure.
Exactly. He combined the unwanted CO2 with ammonia, and voila, urea was born.
Wow.
It might sound simple,
Yeah.
but this was a game changer, especially for agriculture, because urea is a crucial ingredient in fertilizers.
Right.
Yeah.
And this high-pressure expertise, it didn't stop there.
No.
Right. He applied it to
Methanol.
methanol. That's right.
Yeah.
But from what I read, that wasn't a walk in the park.
Took a lot of persistence,
Wow.
a lot of trial and error.
Yeah.
And I think that's something that, anybody who's facing a tough challenge, they can take away from this story. You might experiment, you might fail a few times, but that persistence can really pay off.
It's a numbers game.
It is.
Okay, so persistence is key. What I find really mind-blowing is that he figured out that you could use high pressure to remove impurities from gases.
Yeah.
How does that even work?
So think of it this way.
Okay.
When you increase the pressure, you're essentially squeezing those impurities together, making them more concentrated.
Right.
And the more concentrated they are,
Yeah.
the easier they become to capture and remove.
It's like a pressure washer, but for molecules.
Exactly.
And this has implications for today, right?
Huge implications,
On the
especially
field
with
tank, yeah.
capturing carbon dioxide from the atmosphere. All these insights that Bosch had way back then are kind of laying the groundwork for some of the
Wow.
technologies that we think are going to be vital
That's amazing.
for a sustainable future.
It's amazing how it all connects.
It is, yeah.
So Haber and Bosch, obviously brilliant minds.
Brilliant minds.
And later, Gerhard Ertl, who studied this nitrogen fixation at a molecular level, were there any common themes that emerged from their work, especially from their Nobel lectures?
It's fascinating.
Yeah.
They stressed the need for clear goals, unwavering passion, strong teamwork, commitment to continuous learning.
Just like a recipe for success.
It really is. It really is.
Not just science.
Exactly. They also championed, the power of trial and error, particularly when it came to catalyst development.
Yeah.
And I think maybe most importantly, they remained humble,
Right.
recognizing that there was always more to learn.
Right.
And I think that humility in the face of such incredible accomplishments,
Yeah.
it's a valuable reminder for all of us, a reminder that even the greatest minds are always evolving.
Right.
And recognizing that the journey of discovery never truly ends.
It never ends. But speaking of journeys,
Okay.
let's talk about the sustainability of current ammonia production.
Let's start with the basics. That simple reaction. Nitrogen plus hydrogen equals ammonia.
Yeah, it seems simple. But the challenge is figuring out where to get,
Yeah.
the nitrogen and hydrogen.
Right. We can't just scoop them out of thin air, even though nitrogen makes up a huge chunk of the atmosphere.
Exactly. Right now, the process starts with natural gas. There's this technique called steam reforming, where natural gas reacts with high-temperature steam. That gives us hydrogen gas and carbon monoxide.
Oh, I see.
And then there's another process called air reforming, converts even more natural gas into hydrogen. And it also pulls in nitrogen from the air.
Hold on. We're using natural gas for this. That's a finite resource, right? To make ammonia, which is essential for food.
Yeah.
Doesn't that seem a little, risky? What about that, the Verhulst curve, I think it's called?
Oh, you're absolutely right to bring that up.
Predicts the rise and fall of resources, right?
Exactly. And the Verhulst curve, it's definitely relevant here. If you look at a graph of ammonia production over time, and you compare it to natural gas production, they look almost identical. So we're likely headed for a peak, and then a decline in natural gas production. And that would obviously affect how much ammonia we can make.
And since ammonia is so important for fertilizer and, feeding a growing global population, this sounds like a potential recipe for disaster. Question is, can we break free from this dependence on fossil fuels for ammonia production? And this Verhulst curve you mentioned basically shows how things can grow rapidly and then they hit a limit. And it's really sort of highlighting a problem. Our reliance on natural gas to produce ammonia could become unsustainable.
Okay, so where do we go from here?
Right.
What are the alternatives to natural gas in ammonia production?
Well, one intriguing possibility is to tap into another abundant resource, water.
Water, okay.
Through a process called electrolysis, we can actually use electricity to split water molecules into hydrogen and oxygen.
Okay.
And that hydrogen, voila, becomes the key ingredient for ammonia synthesis.
So instead of extracting hydrogen from natural gas, we could just create it from water.
Exactly.
That sounds promising.
It does.
But doesn't that just shift the problem? I mean, where are we going to get all this electricity to power the electrolysis?
You're absolutely right. The success of this approach really hinges on having access to abundant, clean energy sources.
I'm guessing just burning more fossil fuels is not really the answer.
No, not at all. Imagine a world where we can use renewable energy sources like solar, wind, even nuclear fusion to power the process.
That's amazing.
And this could be a complete game changer, making ammonia production truly green.
That sounds futuristic.
It does.
It's almost too good to be true. Can we really picture a world where we're producing ammonia without relying on fossil fuels?
It's a bold vision, but it's one worth pursuing.
For sure.
And we could even potentially create a closed-loop system by using renewable energy to produce nitric acid from ammonia via the Birkeland-Eyde process. While it is energy-intensive, if that energy comes from renewables, it opens up some exciting possibilities for a greener future.
That is amazing how all these seemingly disparate pieces of the puzzle can come together to create a sustainable system. But let's shift gears for a second and talk about another radical idea that came up in the research. Using ammonia as a fuel. Is that even remotely possible?
Believe it or not, it's more than just a wild idea. When you burn ammonia, you get nitrogen and water vapor. No carbon dioxide emissions whatsoever.
Really?
It's not a perfect solution, but it has incredible potential as a clean fuel source.
That sounds almost too good to be true.
Right.
What's the catch?
Well, there are a few challenges. For one, ammonia has a lower energy density than hydrocarbons. So you would need larger tanks to store the same amount of energy.
So road trips might require a few extra pit stops.
Exactly. But researchers are already exploring ways to overcome this hurdle. For example, they're working on improving the efficiency of ammonia combustion through innovations like swirl combustors.
What are swirl combustors?
Think of them as specialized burners that use a swirling motion to mix the air and fuel more effectively. This creates a more stable flame, leading to reduced emissions and better energy conversion.
So it's like giving the combustion process a little extra oomph.
Precisely. And this can be particularly helpful with ammonia because it doesn't burn as easily as traditional fuels.
So we're boosting the efficiency, but what about the safety concerns? I remember from high school chemistry class that ammonia is pretty toxic. Are we talking about driving around and ticking time bombs?
That's a valid concern.
Yeah.
Ammonia is toxic, so any use of it as a fuel would require very stringent safety measures to prevent leaks and exposure. But remember, we already handle and transport plenty of hazardous materials every day.
Yeah, it really feels like we're on the verge of this massive energy revolution.
It does.
And this simple chemical, ammonia, which started in fertilizer production, could really be a driving force in this whole transition.
It's a testament to human ingenuity.
It is.
And the power of innovation.
Yeah. But it also highlights something important.
What's that?
The need for long-term thinking. Bosch and Haber's work, it was groundbreaking.
Absolutely.
But it also led to these new challenges that we're still dealing with today.
We are.
It's a reminder that progress, it isn't always this straight line.
No.
There's bumps in the road, unexpected consequences, new obstacles to overcome.
For sure.
But it's also a testament to our ability as humans to adapt and find solutions
I agree.
to these problems that we create.
Exactly.
So as we explore this potential of ammonia as a green fuel, we have to do it with a clear understanding of its promise,
Yeah.
but also its limitations.
Absolutely.
And invest in the research and the development to tackle those technical challenges.
Absolutely.
And have these open and honest discussions about the risks and benefits.
Right.
So we can make informed decisions as a society.
I think that's key.
It's like we're at a fork in the road.
Yeah.
One path leads us down this familiar route,
Okay.
continued dependence on fossil fuels.
Yeah.
But the other, less traveled path, it offers us this glimpse of a future powered by clean, renewable energy sources.
Exactly.
The choices we make today are really going to determine which path we take.
That's right. And as we've seen from the stories of Bosch, Haber, and Ertl, we do have the power to shape the future. And it's our responsibility to use that power wisely.
Absolutely, for everyone.
For everyone.
So what does this all mean for you, dear listener?
Yeah.
It means that you're living in a really exciting time.
It is.
Of extraordinary change and opportunity.
A lot of uncertainty, but a lot of opportunity. So stay curious, stay informed, and stay engaged.
Yeah. Well, we hope this deep dive into the world of ammonia has opened your eyes to the incredible possibilities that lie ahead. The last word has not been spoken.
That's right.
There's always more to discover.
Always more to learn.
More to learn and more to achieve.
And more to achieve.
So keep exploring, keep questioning, and keep pushing the boundaries of what's possible.
Couldn't have said it better myself.